Now we need to talk about slope. So if we are going to be graphing lines, and we are going to stick with linear equations, meaning straight lines only, we do have to talk about slope. So slope is something, a number that we use to represent how steep a line is. Like, is it really, really steep, or is it pretty flat? Slope will tell us that. One thing you need to know just sort of intuitively is that if a line has a positive slope, it's going to look like the line is going uphill. So positive slopes are going to look like they're going uphill, and negative slopes are going to look like they're going downhill. So it depends on if you read the graph from left to right or right to left. The proper way to read graphs is always from left to right. So if I just start with any of these lines over here, like this line right here, if I hop onto this line and I go from left to right, I would be sliding downhill. So I know that this line has a negative slope because it goes downhill. If I go to this blue line up here at the top, you can see if I hop on the line there, I would slide downhill. That one also has a negative slope. If I go to this green line, if I hop on this green line and I go from left to right, I would be headed uphill. So this would be harder, right? If you were like on a bicycle, right, you'd have to hoof it up this hill. So that would be a positive slope. So this one is positively sloped. This pink line goes uphill, positively sloped. And then this last blue line goes uphill, but you got to read it from left to right. So you should be able to look at a line and intuitively tell without doing any math at all if it's a positive slope or if it's a negative slope. So then how do you figure out the number, the amount of the slope? Well, another term for slope is rate of change, because what slope measures is how fast a line goes up compared to how fast it travels side to side or sideways. So how fast it rises compared to how fast it runs. And those are generally rising and running. Those are the two words we use for slope. So we always use the variable m for slope. I don't know why it's m. Somebody just decided that, and so we've just always done it that way. So slope is m. And if you're looking at the graph of a line, what you can do is just find any 2 points on the graph and then count how far would you rise and run to get from one point to the next. So you absolutely need to know this formula for slope. It's rise over run. It's really just like a phrase, not really a formula. And I haven't met too many people that don't remember rise over run from their previous math classes. Most people remember that. So let's try a couple examples. Here I have some graphs. I'm trying to figure out the slope of the line. Let's intuitively talk about if it's positive or negative. So this line, if I read it from left to right, it goes downhill. I already know the slope of this line is going to be negative, and I haven't done any math. And the second example, if I were to hop on this line and go from left to right, that goes uphill. I know the slope of that line's positive. So at least I've already got some kind of like insider information going into the problem. So then what you want to do is pick 2 points and try to pick points that are nice and fall on like nice grid lines. Like I wouldn't want to pick this y value because I don't know really what that is. Let me zoom in a little bit. I'm going to pick 2 points that are like on noticeable grid lines. So this one is the point 1, 1, and this one is the point 5, negative 2. And what you do to get from one point to the next is you can draw like a little triangle. And it's like you're trying to figure out, to get from the first point to the second point, how much would I rise and how much would I run? Now the rise, the difference in height, is from 1 down to negative 2. So you just have to count how many blocks did you run. 1, 2, 3. So this is a rise of 3. But we're not really rising, it's more like we're falling, right? So that's where the negative's going to come into play. We're actually dropping 3. And to get from here over to here, how far would you have to run? Well, 1, 2, 3, 4. To get from 1 to 5, you would run 4. And you're running in the right direction, so that's positive. So my slope would be the rise over the run. If you want to take all the signs out of it, you can just say 3 and 4, and the fact that it goes downhill is your negative. You can just work in the negative that way if you want. So let's look at the next one. And it's got 2 points already highlighted that will make life easy if you'll use those 2 points. So I can either run and rise along the axes, or I can rise and run above it. You have a choice. You can go under or you can go above. It doesn't matter. I'm going to run on the axes because I think that's easier. So this distance, how far I would have to run from -6 over to 0, that would be a run of 6. And how far up would I have to go? 1, 2, 3, 4. It's like you'd have to run 6 blocks and go up 4 floors to get to the next point. So my slope is going to be my rise, which is 4, over my run, which is 6. And if you get a fraction that you can simplify, you should try to simplify it. So like each of those can be divided by 2. So 2/3 would be the run. So let's see, what if we don't have a picture? What if we just have 2 points that are given to us and we're supposed to figure out the slope? Well, you could draw a picture. There's nothing wrong with that. Or you could use an alternative formula. So let me show you this formula. So how to find the slope of a line that passes between 2 points. Since both points are x, y, I had to do something to like differentiate between the 2 points. So I put subscripts of 1 on the first point and subscripts of 2 on the second point. And so what we're going to do to find the slope of getting from the first point to the second point, the way that you do it is you do rise over run. So if you can just remember rise over run, that should help. Rise is your vertical movement. And so you have to look at how much would you rise to get from y1 to y2, to get from your first y value to your second y value. Those are your vertical movements, the y. So how much would you rise? You'd subtract those. And to figure out how much you run horizontally, you would subtract the x's. Do you start with 0.1 or 0.2? It doesn't matter, but you just have to be consistent. So we did y2 minus y1, so second y value minus the first y value, over the second x value minus the first x value. So you see how it's consistent? 2 subtracts 1, 2 subtracts 1. You just need to be consistent. So if you're just given 2 points, this formula will help you get by. If you can't remember the formula, draw a picture. Draw a quick little sketch of the 2 points and then just do the little triangle to rise and run. That's always a good thing to fall back on when you don't remember the formula. And again, it doesn't matter which is 0.1 and 0.2, you just have to be consistent. So let's do one example. Suppose a line passes through these 2 points. So I'm going to call that my x1, y1, and my x2, y2. So x and y for my first point, x and y for my second point. What's the slope of the line? Well, let me write down the formula. y2 minus y1 over x2 minus x1. We're doing vertical movement, rise, over horizontal movement. So y2 minus y1, 1 minus 5, over 2 minus -3. Be careful of that minus minus. Now 1 minus 5 would be -4. And 2 minus -3, that's going to turn into 2 plus 3, which is just 5. So our slope is -4/5. If you switch the points and do the formula again, you should get the same answer. So again, let me just say, if you forget the formula, don't forget rise over run. So if I go back 3 and I go up 5, and I draw that point, like right there. And then if I draw the point 2, 1, and if I want to know what the slope of that line is, you just figure out, well, and you go from one point to the other. It doesn't matter which direction you're going, but you think, well, how much would I rise and how much would I run? So I'll go from left to right. So I would have to drop down, and then I would have to run. So I'm at 5, I'm dropping down to 1. That's a distance of 4, and I dropped. And then from -3 all the way over to 2, that's a distance of 5. So -4, divided by 5. So you can totally do it this way if you don't remember the formula. But if you can maybe remember the formula from your last math class, if you kind of already have it partially memorized, it's a really good one to use, and then you don't have to waste paper drawing a graph. But either way you want to do it is fine.